Good evening, good afternoon, good whatever time it is you're watching this. Welcome back to my weekly live stream around developing Node-RED. This is, I think, must be about week 10, week 11 of doing this live stream without missing a week, which is quite pleased with. Just seeing there's some horrible flickering going on the camera. Let me just sort out my camera so you don't get flickering because of the lighting. There we are. Cool. That's done. So, what are we doing? What are we here for? So this is my weekly live stream about developing Node-RED itself, not using Node-RED, but actually trying to do some development work, design work, discussion around Node-RED itself. And hi to the guys in the chat. Nice to see you back. So what's going on? What's been happening? So the topic from last week, for those who've watched that one, was around the new Pluggable Message Routing feature. And we're going to continue in that theme. We're going to continue on that topic this week. The design has moved on a fair amount, not so much on the code side, so spent most of my time on this feature last week. Most of the time that I spent on this feature last week was more around the design. So if you followed some of the discussion in the forums through the week, then you would have seen some of this already, but I just wanted to for those who are coming to this sometime in the future, want to try and sort of recap how the design has evolved over the last week, so people who watch these videos can sort of follow along a bit more about how this has evolved. But also want to talk through a bit more where I see this going now, because it's the design's taken a slightly different approach to what I'd long assumed the approach would be. So let's think what we're going to talk about. So to recap just what this is about, it's the Pluggable Message Routing feature. So this is trying to provide a way to put custom code in the messaging path. And that custom code could be additional logging, it could be message routing. So one of the use cases is having a remote router that can send messages to a completely separate runtime. So it's code that has sort of intercept the message and send it somewhere else and not try and route it locally. The Flow Debugger would live in this area. The Flow testing framework will live in this area. So the concept was always around this idea of creating, like Express middleware, a set of stacks, a set of layers of code that the message passes down through each layer, being passed from layer to layer, and each layer can do something before either passing the message on or halting that message, because maybe it's sent the message elsewhere itself. And the model we kind of always assumed was going to be this stack of layers, and somehow the user or the system would be able to customize that stack with custom code. That's been my sort of conceptual model for this feature for the last, 3 or 4 years of this being an item on our roadmap without really spending time designing it. But now we are spending time designing it. The design has taken a bit of a turn, and we're now looking at a slightly different approach. So, maybe just a couple words around the design process. So, it's probably obvious to those who follow. I do a lot of the main feature development of Node-RED, but I do try, and I'm trying to get better at designing in the open. So part of doing this Twitch is to share more of the thought process as it goes on from the beginning. But one of the things we have had for a little while now, particularly when working with the contributors from Hitachi, where they've got a lot of interesting features that they want to work on. Just trying to provide some structure to how we discuss design and how we approach it. Is in the Node-RED organization on GitHub, there is our designs repository. So this has a list of design notes for features for Node-RED. The README lists out, the README is out of date, I'll say that now. This list of design notes in draft, status versus in progress versus complete. I don't think we do a good job of keeping that up to date with reality. Sometimes it's better just to dip it straight into the designs folder, and you can see lots of different designs. For example, the design note for the flow outliner. So in 1.1.0, the new sidebar. In fact, look here, you can see this was my first PowerPoint mock-up of what it would look like. I've got, when I want to sketch and share with others high-level UI mock-ups, I've actually got a PowerPoint template that has Node-RED components in that I can quickly build little mock-ups in a somewhat consistent look and feel. Anyway, so yeah, the designs were key. So there's a bunch of stuff. Some of this has already shipped, some of it hasn't. And so there's a task to go through and try and keep that up to date. And then there are pull requests, which are proposed design changes, new designs, new features, some of the things coming down the road. Now, in amongst those, and it's been open since March last year, and this is how long the Pluggable Message Routing has kind of been discussed, or at least at a high level concept. We raised a very preliminary design note for it early last year, just before we decided actually to drop it from the 1.0 plan. So it got no more attention until a couple of weeks ago. So if we just follow through to the message routing branch, because it's rather than view the pull request, it's easier to go to the branch and look at the files, because you get the images in line. Somewhere in here, pluggable message routing. So this is the current design note. This is the pull request for this design note. This is the current status of it. And this is we have a standard template for design pull requests. For design notes, where it needs to have a basic summary, a list of the authors so we know who's working on it, then the detail. And in this instance, I've sort of listed out some of the interesting use cases for pluggable message routing. We've talked about the Flow Debugger, flow testing, flows that span multiple runtimes. And then it gets into the high-level design. Now, this is what has changed since the last live stream. So the original conceived idea was this configurable stack of router layers. But I think, I touched on it briefly last week. There are some usability issues with this idea of having a single stack, because the order is so important of the stack. Which layer goes before which, and it's fine if you, the person configuring it, are the only person who has any say on what that stack is, and you know what you're doing. But as soon as you've got things like the flow testing feature and the flow debugger, which would want to insert themselves into this stack, and it might be a completely custom stack already, then it just becomes a complicated thing to manage and to try and make sure it does the right thing. So I talked about it briefly, I think, in the live stream. There's this other concept around, rather than having a stack, instead having a well-defined life cycle of a message from the point it gets sent by one node to being received by another node. There's a well-defined series of steps it has to go through, and looking at how we can break those steps up so that there are more discrete points along that process where custom code can be added. So kind of changes from being one big stack of layers that a message passes through to lots of mini stacks along the way. So let's show the picture. So this is the concept for the pluggable message routing feature. So what we've got here in this diagram, can I make that a little bigger for you? So what we've got going on here is, so on the left-hand side you have a node, and on the right-hand side you have a node, so sending from the left to the right. If you ignore the labeling for the moment and just look at the boxes and arrows, the main arrows, so the node starts by calling send, and that can be a single message or it can be an array of messages destined for different outputs, or multiple messages on one input, endless combinations of what that could be. But that's what the node at its lowest level does. It calls that send. Now, in the current code, as part of doing that, the node, as in the sending node, it works out what messages need cloning, and it clones them. It gets hold of a reference to the node it's being sent to, and it does all of that work. And then the node makes individual calls for each individual message to actually send that individual message. So that's kind of shown here by this initial stack of messages coming out of the node. That's an arbitrary number of messages being sent in a single call. It then goes through a layer which turns it into a series of individual messages. Now, in this new design, that is still what happens, except some of the responsibility changes. And we'll come to that in a minute. So those messages get passed up to the new router component. That router component does the work of what we talked about last week, the local router. So that router looks at the individual message, says, right, who do you need to be sent to? Do you need cloning? And then taking the appropriate steps, and then asynchronously, so that's what this diagram's trying to show. This first orange arrow returns at that point, and a second orange arrow starts, because this is an asynchronous break in the call stack. So the router then calls the receive function of the destination node, and the color changes in colors of the messages is meant to sort of indicate the messages have been cloned at that point if they needed cloning. So this first message didn't get cloned, but the others did. So if you think of that as the life cycle of a message being sent between two nodes, then we can start to identify some interesting points where some custom code might want to live. And that's what the numbered labeled bits are. So the naming is, I stared at this today, and I'm not 100% sure I'm happy on the naming scheme in terms of pre-send, on-send, post-send. There's a little bit of inconsistency here in terms of what do we consider a pre-event, on-event, and post-event. But naming aside, these are the steps. So pre-send is a point in time when so the idea, these are going to be named points, and through some mechanism custom code can be attached to any one of these points or multiple of these points, and so that allows the code to target more sensibly where and when it should run based on what does it need to actually do. So pre-send is would be handed that arbitrary array of messages. So it's kind of the raw the raw object set that the node.send has been called with. So at that point, no cloning has happened. So you've got to be careful, because there might be multiple references to the same message object in amongst those, which is what the cloning fixes. But it's, very early on, pre-send. Then there's this pre-route phase, and at that point, that will get triggered once for each message that is going to get sent. So at that point, it's done the work to identify the destination, or at least the ID of the destination. Well, the key thing is it's no longer this arbitrary array. It's pre-route gets called once per message that is going to be sent. On send, so at that point, the local router has actually identified the concrete node it is being sent to, and it has cloned the message if it's needed to. Post send then gets called after the message has been dispatched. So because it's asynchronous, that doesn't mean the message has arrived. It just means the message has now been queued up for delivery asynchronously. Then switching over to the right hand side, you've got part 5, which is on receive. So that will get called when this node is about to be given a message. Post receive will get called after all of the node's input handlers have returned. And if you recall, a node input handler can complete asynchronously. So post receive will be when the call has returned, but the node may still be processing the message. So there will be hooks for on done and on error. Now, the exact function signature of all of these things need to be defined. The exact information they're given needs to be defined, but this is the concept. So we can sort of break that up a bit and think, well, the flow, how does this satisfy our use cases? So the flow debugger, for one. So familiar with programming, a common ability in a debugger is to be able to set a breakpoint. And a breakpoint basically says, in normal code, when execution reaches this line of code, pause and break execution and let us examine the state of the system. So in Node-RED, breakpoints would be a very similar concept, except they're visual breakpoints in that you'll be able to say when a message is being sent by a node on this port, or when a message is being received by a node, break and freeze the passing of messages between nodes and let me examine the system. So the flow debugger would be able to register a hook for pre-send, because it will then be able to, when it's handed that arbitrary array of messages, it'll be able to check them all to see, does any of one of these correspond to an output that has a breakpoint on it? Likewise on receive. So you'll be able to choose whether the breakpoint is on the sending side or the receiving, which, when you're talking about a single wire between nodes, is a bit arbitrary as to whether it's the send or the receive that causes the break. But as soon as you've got nodes with multiple wires and multiple routes between them, then being able to choose send or receive is much more relevant. So again, the on receive step would allow the breakpoint to get triggered and stop the message passing before the node is given the message. For flow testing, well, flow testing has 3 different use cases. One is, or 3 different aspects. One is verifying what a message looks like before it's given to a node, verifying what a message looks like coming out of a node, and then being able to substitute a node with predetermined behavior. Because if it's a node that writes to a database, when you're running a test, you might not want to actually write to a real database. You want to simulate a successful write or even simulate a failure. So for verifying messages that arrive at a node, again, on receive is the hook for that. Verifying messages being sent by a node, pre-send or pre-route would both work there. And then being able to stub out a node, well, pre-route would be able to intercept the message and say, right, you want me to send that to a node that is being stubbed out for this test. So instead, I'm going to pass it to something, a test node entity, and stop the onward delivery to the real node. So the flow testing facility would be supported by this, and the remote distributed Node-RED, again, pre-route step, would be able to intercept every message and decide where to go. Another use case that came up on the forum, thanks to Bart, was around custom cloning behavior. So this is an interesting one. So at the moment, Node-RED tries not to clone messages, but there are as soon as you have multiple nodes wired up, it has to start cloning objects to avoid one branch of the flow modifying the messages being sent to a different branch. If you aren't familiar with this, there was a good blog post about this in the 1.0 timeframe on the Node-RED blog, sort of explained some of the changes we made to message cloning. The downside is Bart's got some interesting nodes that do stuff with large image data, OpenCV data, where you really don't want to be cloning that data unnecessarily. So one of the changes that this is going to bring in is changing who is responsible for doing cloning. Currently, the cloning happens at this very early stage where the multiple messages are sort of separated out into individual messages. It does all the cloning then. But if you are doing a distributed Node-RED where some of your messages want to get sent to a remote system, well, chances are when you serialize that message to send it over the network, it would have been a waste to have cloned it earlier, because you're going to serialize it, send it over the network, and that's effectively cloning it. So one of the things possible that we'll do here is this code up front that splits the multiple messages up into individual messages. Rather than clone the message, it will set a flag on the object that gets sent through that flags should that message be cloned or not. And then the router layer will honor that flag. If the flag says you need to clone this message, it will clone it. So what's nice about that is then this pre-route stage, or indeed the pre-route stage, would be able to override the clone flag. If for some reason it determines that this message shouldn't be cloned, despite what has happened earlier, it would be able to set that flag to false, and avoid any further cloning. So then, debating myself how much just to read aloud the design note, which is there for you guys to read. But what this design note does not yet do is define the exact signature of the code that couldn't be registered at all these stages. But what we do know they will operate on are these send event objects, I've called them. Whether that's what they end up being called, I don't know. But it's basically an object that wraps the message that the Node-RED flow is dealing with. And so it's an object that wraps it, that will have the message. It will have information about the sending node, so its ID, a reference to the node object itself, and what port it's being sent on. And that's an important one because for the Flow Debugger, it will need, if you've got a breakpoint on, in earlier iterations, when all we worried about was where we're sending it to, in the case of the Flow Debugger, that's not enough information. If we want a breakpoint on the output, we need to know the port it's being sent on. And then the send event object will have a destination object, which will start out with just the ID, because when it starts, we don't have a handle to the actual concrete node object that it's going to be sent to. That comes later down the process. But we will make sure there is a property called node, which is either null or undefined. And then, as I mentioned, this clone message flag. So the Boolean flag that will determine, which will be the instruction to the router later on, whether it needs to clone this message before it sends it on. So yeah, the design note then basically talks through everything I've just talked through about how the different scenarios that we've identified, custom cloning, remote message routing, Flow Debugger, flow testing, custom logging, how all of those can make use of these hooks. So in terms of how these hooks will get used by the end user, well, at this point, I don't know how much the end user would care about these hooks. These are more internal hooks that bits of code can register themselves with in order to provide some functionality. So I don't know at this stage, whether the user would be expected to ever explicitly set this stuff via their settings file. Now, I suspect we will provide a way to do that because it still has its uses, but for most cases it would be more the fact that the user has installed like the flow testing plugin, and that just deals with registering all the code it needs to. So what's more interesting is the runtime APIs, the actual code APIs, because that's what functional code will call. And it will be something along the lines of red.something. We don't know yet exactly how that will be spelt. Add hook, then the name of the hook, which will be one of these pre-send, pre-route, on-send, what have you. And then the function that should be called. And then we'll provide a remove hook so that things can tidy up after themselves if need to. A proposal in this design is the name would take the format of, well, it can optionally be suffixed with an identifier. So in this example, something might register a pre-send hook with the label Flow Debugger, which would then allow remove hook just to remove it by name rather than by reference. And I could imagine a remove hook where you do star.flowdebugger and it would remove all the hooks with the Flow Debugger suffix. Little things like that just make the API a bit easier to use. But anyway. So that's where the design has got to. Now what has kind of gotten, why I've not charged ahead with writing code for this yet, is this idea of adding hooks to the lifecycle has kind of opened up my eyes to some other areas where that could well be useful. And some other use cases beyond message routing that would be better served by having well-defined hooks that people can insert code. Let's just have a go at this. Right, if I switch to this one, let's try the whiteboard again, because this almost worked well. It worked quite well last week. It was fun, but I've not done anything to try and tune it, so this could go horribly wrong. So when we think about the flow testing or flow debugging, obviously they aren't just going to be registering bits of code in these hooks in isolation. They're part of a bigger piece of functionality. And when we look at the ability to build a remote message router, that remote message router needs to have a overall view of your flows. And we've talked around this idea of the groups feature added in 1.1.0 as being a way to add extra metadata against nodes. And that metadata could be, for example, information about where to deploy those nodes to. But we need a way for that information to be got into that custom code and allow custom code to have a view of what is the configuration. So when we think about the deploy process, right, this is going to work. Right. Good luck. When we do the deploy process, as in the user hits deploy in the editor, this still feels slightly off. I don't know why. I think it's mapping. Oh, anyway, it just feels like this drawing is going to get squashed because it doesn't feel natural. Anyway, when the user hits deploy, down comes the flow JSON as this big array of objects down into the runtime. And what the runtime does is it first does a whole bunch of work to build up a picture of what is being deployed, because it needs to work out the differences between what's being deployed and what is already there. So there's a bunch of work to turn this array of node objects into this bigger object that has that array in it, but it's also got the diff. Ooh. Oh, this is almost readable. There we go. Apologies for my handwriting on this graphics tablet. It builds up that diff so that it knows what has changed, what are modified flows, what are modified nodes, what needs stopping, what needs restarting. It then writes the flow configuration to storage. Sorry, a bit fiddly. Right. That flow configuration then shoots off into the storage system. There you go, a little drum to store that in. Then, once it's stored the new flow configuration, it proceeds to stop all of the nodes that need stopping because they've changed. Once they're done, it can then do the start, and it then starts all of those nodes. And I think I did a walkthrough of that whole process in one of the earlier videos when we were trying to track down a bug with the node removed flag. So yeah, I stepped through the code for that in an earlier video if you're interested in more detail. Now, what I've been trying to do today, and haven't quite got there yet, so I don't have a neat drawing to show you, is thinking about, well, in this sequence of steps, where could hooks be added to do something interesting? So there is a point up here where the initial deploy arrives. So we're handed just sort of the raw flow JSON, including possibly credentials. There's a point here where we have not only the flow by, hold on, so up here, don't know why it's tricky to write. Right, flow, then here we've got the flow plus diff. Oh dear, this is okay. We then have this point here where things get written to storage. Now we already provide a ability to provide a custom storage plugin. But I think there's something subtly different here where you don't want to provide custom storage, but you do want an opportunity to manipulate what goes into storage somehow. Then we've got a point here where we're just about to stop the flows. We've got a point here where we have, that's about to stop. We've got a point where we have now stopped the flows, a point where we are about to start, and then a point here when we have finished starting. So when we want to think about what is the custom code that could, or what information would these flow routers or testing or debugger need? Well, it's going to be some of these things. It's going to be recognizing what is the incoming flow configuration. The diff of it might be useful when you're stopping or starting. And the other thing, of course, is the overall runtime life cycle. So in the overall runtime life cycle, we've got knowing when, let's see, where am I? So you've got the overall life cycle of, you've got the start of node red. You've then got its sort of general life cycle of running flows, deploy cycles and all that sort of stuff. And then eventually at some point it's going to stop, which could be a normal controlled stop or a shutdown. And if you're doing a custom message router, if you're doing like a remote messaging thing that needs to establish a connection to a remote system, you need to know when to close that connection. So there's another set of hooks around the high level life cycle of Node-RED. So I'm still trying to work out what these points are, but it feels the right thing to do. Now, this is turning into a much broader conceptual piece than just message routing, because once we have the ability to do these sorts of hooks at key points, it actually suddenly becomes much easier to do a lot more custom behavior within Node-RED. Let me how I'm going to do this. Right, I'm just going to take a quick screenshot of what I've just drawn. Not because it's a piece of art, just I think it is useful for me to keep hold of these scribbles I do so I don't have to play back the video to remind myself what I drew. So one common... Oh, and this is the other thing. The whiteboard app I found no good way just to clear the screen without actually literally going around and erasing every bit, which is useless. There should just be a one button. Hold on, let's see, what does this do? Maybe if I make that super big. Eraser. That works a bit better. Anyway, I'll keep talking whilst I colour in the screen. I need to find a better whiteboard solution for this live stream. So we've got the storage plugin. We also did a whole bunch of work in, I think, 0.20 to split out the runtime and editor APIs. So there is actually a huge API surface already published that we say it's possible to put custom code between the editor and the runtime, but the way it's done is you kind of have to implement the entire API in order to plumb the whole thing, the layers together just to add in one small bit of custom. And for a lot of the use cases, it's not very useful forcing it to happen that way. So at the moment we've got let's say, so in the code we've got this module called the editor API, and then we've got the runtime API, or the runtime module, and those two get plugged together, and they fit nicely. But the point being, with the existing code, you could plug them together by inserting your own shim in between them. I'm suddenly got very conscious about accidental, inappropriate images. Anyway, so that's far from ideal, that you have to implement such a large API. It would be much nicer to be able to just insert smaller parts. So one interesting concept is, here's the runtime, which is running flows for everybody. And then we have user A logs in on this machine. User B logs in over here. Now, today, they would see exactly the same set of flows. Because Node-RED is not multi-tenant, it runs everyone's flows at once. A and B see the same stuff. Well, if it were possible to put a little bit of code on the API that the editor calls to get the flows it should display, that bit of code could, just for that one function, the get flows, it could say, user A, I can give back a filtered view of the flows to user A, and I can give a different filtered view back to user B, so they actually get a different view of what's running. And likewise, when the set flows, the deploy button's pressed, that code could say, right, it's user B deploying some changes. I know they're only deploying their piece. I need to merge that with everything else and then push down that complete view. Now, how practical this is, I don't know, but the point being, having hooks is potentially a much easier way to insert those little bits of code rather than have to re-implement a huge API layer. That's why I'm now looking at this hooks idea on a broader sense. But I'm not going to try and design all of that for pluggable message routing, but it's kind of recognizing that that's this is the bigger picture. And, this is why we spend time doing these designs, is it opens up actually the bigger picture of a feature, and it now means we want to make sure these hooks fit in a bigger sense of what the hooks are for. It's not just about message routing. That's one application of it. There's a lot more going on. So the design task at the moment, which I'm not going to get into now, is really about what are those right hooks? What's the minimum set? We've got let's switch that. Come back. There we are. Hello. Unfortunately, I closed the wrong window. Somewhere here, I've got my picture. Oh, I saved it to the desktop and I can't get to the desktop. Anyway, no worries. So there's the high-level start and stop of the Node-RED runtime, and then there's the basic flows around when a new configuration is deployed and nodes are being stopped and then restarted. So the next rev of this design will have a similar diagram to the one we're showing here, but for those parts of the life cycle and what those hooks are. Because I think those will be key to the sort of functionality needed for all this to hang together. So to give a little bit of a sense of code, and I know this live stream is meant to be about me developing Node-RED, and this has been 47 minutes of me talking about design, which, but this is the thought process, so I hope this is useful. Sorry, I just noted in the chat. What about custom events from a custom node? Something like MQTT node with connection status, but sent behind the scenes. So nodes. So the MQTT node already does have its own little internal event emitter that handles those sorts of things. We don't want to introduce a different way for nodes to communicate with each other, if that makes sense. We provide node status, and node status is kind of for connection events. That's meant to be the standard way for all nodes that need to broadcast that sort of state information would use the status layer. Now the MQTT node, because it's got the MQTT broker and the input node and the output node, they do have their own little internal event listeners amongst each others so that they know what's going on with each other. But that's kind of an internal implementation detail, that it's not part of the externals of the node. But that's fair game for any nodes to do that. But not looking for custom nodes to add custom hooks at this point. That's not to say never. It's just still early days with these hooks to try and get this right. So let's actually make a bit of a code change. So in the design, we talked around this idea of these send event objects. Let me just copy that into our code. What we're looking at here is node.send. So this is the function called when a node is sending a message, and message is that arbitrary array. It could be one message, it could be an array of multiple messages. And at the moment, in the case that it's the optimal case, it's got a single wire, so we don't have to do any cloning, no iterating, and message itself is a single message. At the moment, it calls up to the parent flow with the send of itself, the ID of what it's being sent to, and the message. Well, we don't want it to look like that anymore. We want it to send a message event. So we're just gonna, at the moment this code is just kind of indicative, if that makes sense. Again, it's all part of exploring the problem. So we're just filling in these fields for this optimal case. That this underscore wire will be the ID of the node. We'll leave node undefined in there, and we want clone message in this case to be false. And then, rather than pass all that, we'll send up the message event. Okay. And then we come down to so this is the other case where there are multiple outputs, multiple messages, or multiple wires, so that it has to do a lot more iterating. And what this does, it already builds up a list of what it calls send events, which look completely different to the send event we're introducing. It's entirely internal in the node, what that looks like. But we're going to create the message event. Just need to get all the variable names right. So in this instance, message is M. Source is this ID. Port. So we need port, I believe, is J. Because, this is iterating over each output and then what it needs to do. Destination, well, that's going to be is that right? Yes, that is right. node's undefined, so we don't know it yet. And then clone message false. Well, now this is where we need this little bit of logic. So at the moment in the existing code, message sent starts out as false. If we get to this point and we say we've already sent a message, every subsequent one needs to be cloned. Otherwise we send, if this is the first message we've sent, we send it as is, and then we set message set to true. So next time we will do some cloning. So what we're going to do is just say clone message, set it to message sent. We're going to stick our message event onto this array of message events. And then we set message sent to true. And we can get rid of all of this. I'm just going to comment it out because I know I want to come back and reference that in a minute. So that builds up all the send events. It then does a little bit more work down here. It just makes sure that all those messages have a message ID set on it. But we've changed the property names, so I just need to fix that up there. And then we call flow.send with that event. The whole event object now, not the piecemeal parts. Okay, so now we go up to flow.send because we've changed its signature. And that's now a send event. And then this is code from last week where that is now deferring it to the router layer. And with this whole new design, I suspect a lot of things have to change, but I'm just kind of building it up slowly based on changes we already have in place. So, yeah, we're coming into the router.send here. No, that's the wrong one. Router.send here. And again, this is now the send event, which passes it to the default router, which is still the stack of router concept. So this is all going to change, but again, it just helps to build this up piece by piece. So here, we'll come to that in a sec. So the default router then goes through each layer in the stack, as it were, and we're going to pass through the send event. Here's our little dummy post message logger, just to prove the idea. Send event, but now everything's changed. So send event has a source property. We want that. We want send event destination ID and the send event message. Yeah, now do us. And in our example local router, it gets given a send event. So now we can send event source node we know is set. We get its flow. Still not entirely happy about that, but it'll do for now. And then we want the send event destination ID and the send event dot message. Now that's all good, except you may have spotted I commented out here the cloning, and we set clone message to true. So what we now need is to introduce into local router the cloning. So we want to do that. We don't want to do that inside the set immediate because we want to clone it synchronously to stop any modifications. So what we're going to do is, well, we said send event.clone message is the Boolean flag to say whether we want to clone or not. So if that's true, we're going to do red utils.clone message send event message. Otherwise, clone message is false, so we can just pass through send event message as is. And then we use that message variable. And before that, any of that's going to work, we just want to go and grab red util is part of the node red util module. So standard module for doing that. Yeah, so I think that all works. If we head back into our code and run it, frankly, you're not going to see anything different. It's going to run, messages are going to pass, but I think the key thing we've done here is conceptually we've moved where the cloning happens from within the node to later on in the process. Started flows, good. So hopefully, yeah. So messages get through. We haven't broken the basic messaging path, and you can see this was the custom router layer we added, which just spits out. So question in the chat, are we planning to have some performance tests as part of the standard test suite? Maybe there are already some, to check if changes in the message routing influence performance in a positive or negative way. We do need to have some performance tests. Whether they're part of the standard Travis test suite that get run all the time, I don't know. Just based on, I don't know how reliable the numbers we would get would be running on Travis. Just in terms of, if we were unlucky and we were to get a run on a noisy VM, constrained VM or what have you. Need some investigation there. But yes, we do need to be conscious of the performance impact of all of this. Obviously, putting more code in the message in the messaging path does have a performance overhead. But so that is going to have to be a very important design constraint for all of this work. We need to make sure we optimize as much as possible throughout the whole message handling path. And in fact, this is, again, doing some research on Fastify and some of how they approach it. I'm still learning how to optimize node code. There's far more I don't know than I do, and there's lots of little things along the way that I need to learn. So a good example here is the fact we're now going to be wrapping every message in this message event object. At this point where we create the message event object, you'll note I'm setting this destination property to undefined. And some might say, well, okay, for completeness that might look nice, but why bother? And the reason you bother is it allows the V8 engine to optimize how it understands this object, and that it understands that this object has a destination.node property at all. There's a really interesting blog post that Fastify's, I found on the discussion for Fastify from a guy whose name I forget. I shouldn't have forgotten. But for an object that you're going to be creating lots and lots and lots of, it's far more efficient for the V8 engine to be given as accurate an image of what the object looks like straight away, rather than it might be able to optimize a bit if it was done immediately afterwards like this, but if we had some other property called foo, it's far better for the V8 engine for it to be done like that than it would be to add an extra statement below. And it's all to do with how the V8 engine optimizes object properties and how it knows what properties an object has and how it looks them up. That's a really interesting blog post that I will try and dig out and link to some way if you're interested. And it's those lots of little micro optimizations that I now want to go and see where are the other places in the Node-RED source code where we can start applying them just to make them as efficient as possible. And that's also one of the potential benefits with this hook scheme, rather than doing the layer stack, is being able to optimize whether, if there are no hooks registered for any of these points, optimizing the hot path through the code so it doesn't even have to spend time looking or checking to see if there's any code to run. So that for a system that doesn't have any hooks registered, so you have not got the Flow Debugger turned on, you've not got flow testing enabled, and you're not doing anything else custom, then there's as little overhead as possible to these hook points existing, but with no code registered on them. Now, the current code allows node A to go straight to node B, which is frankly as optimal as you can get, because it minimizes any handling between the two. So yes, we have to add some additional code to that path to support this model at all, but that's just got to be part of the overhead of adding in these features. How big an overhead? Yeah, we'll have to do some performance testing and look to see if it's a genuine issue. We don't want to prematurely optimize anything, but nor do we want to put things in that are causing unnecessary burden. That's going to be part of the work. And again, this is all part of trying to figure out whether this is in the 1.x time frame. Maybe this doesn't actually land until Node-RED 2.x in April next year, which is a long way off. But I don't know. I would like to get some of this into the 1.x stream, because I think that some of this functionality will be useful over the next 18 months for users in the 1.x stream. But it might be, we'll just have to wait and see. It's all speculation at this point. So that's an hour of the design work for the pluggable message routing, and hopefully sort of explain the shift from the pluggable layers to these defined hooks, but also how this defined hook approach can broaden out across the whole runtime and actually provide, I think, a model for extensions that opens up and enables a whole bunch of more interesting things. But time will tell. We'll see. So there's all of that. I'm gonna, this week, as well as trying to think a bit more about these runtime wide hooks, also perhaps try and lay down some actual code, because the code I was briefly updating just now is still modeled around this idea of a layered router. So I need to now work out, actually, if we switching to this registered hooks model, how does that change the layout of the code, and what's the knock-on effect of that? I suspect we'll still have a router component. Well, I say that. We may not need still to have a dedicated router component. This could all be functionality that's more joined to the flow object in terms of dispatching to the different hooks. I don't know. That's the work to do, and I think I'm sort of learning. I don't do well trying to do this sort of blank page design work live to an audience. Some of it I need to hack around with myself offline, and then come back and sort of share what I've done. So yeah, we'll see. Also, I will say now, for regular viewers, it is the school holidays now. We're having a bit of time off in August, so I will endeavour to publicise when I won't be streaming. But if I go on holiday and I forget to update Twitch, I do apologise now. But no, I will endeavour to publicise when I'm away, or at least choosing not to spend my Monday evenings with you very fine people. So I hope that was useful. Bart, I'm sure if you're still watching, I know you don't manage to do the live stream, so you'll be watching the YouTube video. So I promise, I hopefully have remembered to get that synced up to YouTube nice and promptly for you. I hope that's interesting. If you haven't followed it, everyone else, there's been a really interesting, Bart has asked some really good questions, probing questions this week. It was a really good sort of design discussion around this whole feature, and has certainly helped flesh out in my head a lot of what we've talked about. So please do join that thread if you have more questions about this feature in general, or more suggestions on anything you've heard. But yeah, I'm going to wrap it up there. I'm going to wrap it up there. So thank you very much for joining again. Always good to see you guys. Nice seeing you come back each week. I continue to hope that this is interesting to you guys. It is useful to me talking this stuff through out loud. It does help me think it through when I'm talking out loud, and my kids get bored when I try and talk them through it, but that's fair enough. Yeah, time for me to go. Thank you, everyone. Have a great week. Stay safe. Wear your masks if you need to wear your masks, and all those public service messages. See you soon. Bye.